Alright guys, we're going to talk about pressure. This should be a pretty quick video, so here we go. Alright, what is pressure? Well, right now we're feeling pressure on us. So pressure is your force being displayed over you over a certain area. You have pressure on you. You can kind of think of it like this. Think of it as someone steps on your foot, alright? So you got the whole shoe pressing down on your foot over a certain area of your foot. You're putting pressure on it. Now, think of a high heel stepping on your foot. Trust me, that hurts a lot more. Don't ask me how I know that. So, why does it hurt more? Because you have, let's pretend it's the same person stepping on your foot. You have the same force going down, but with a high heel, it's in a much smaller area. And so since it's in a much smaller area, alright, since it's in a much smaller area, there's going to be more pressure on you in that little small area. So pressure is a force that's pushing down on you over a certain area. How do we do pressure? Well, pressure, alright, its variable in an equation is P. So let's talk about pressure on us right now. There is lots and lots and lots and lots and lots of gas over us right now. It's all making up the atmosphere, and it goes up higher and higher in the atmosphere, okay? Now, that gas is hovering over us, alright? It's kept in by gravity, yes, but that gas is over us, and it is pushing a pressure down on us, alright? Now, I've heard that that pressure is about equivalent to if you put a refrigerator on you, and you lay it down, you put it on you, that's about how much pressure is on us. Now, you're thinking, well, I'm walking around, I don't feel like a refrigerator's on me. Why don't you notice it? Well, you've been around it all your life, okay? So, the pressure that's all around us, we don't really notice, alright? But if you ask someone that has, like, they get headaches based on weather, lots of times it's because a high pressure system comes in. Right? All that means is you got a little bit more air pressing down on you, and some people are sensitive to that and can feel it. All right? So pressure is P. The pressure over us is caused by the atmospheric air over us. All right? Approximately, if you go down to sea level, okay, so you go on to sea level, all right, there's a unit we use for pressure that's equivalent to being at sea level, and it's called atmospheres, okay? It's called atmospheres. And one atmosphere, which we write ATM, okay? One atmosphere of pressure is on you at sea level. Okay, so when you go to the beach, if you're standing right at the beach, that's sea level. At sea level, you have about one atmosphere of pressure over you. So that's where that comes from. Okay? Now, when you go up in elevation, so when you go from a beach to here to Atlanta, Atlanta is higher, right, than sea level. So as you go further and further up, there's less gases over you. Since you go further and further up and there's less gases over you, you have less pressure. So as you go up, the pressure goes down. If you're climbing up a mountain or driving up a mountain, as probably most people are going to drive it versus climb it, right? The pressure gets less and less and less as you go up in the mountains. You'll notice if you go in the mountains, maybe it's a little harder to breathe. That's because if there's less pressure over you, what that means is there's less atmosphere over you. And what's in the atmosphere that we breathe? Oxygen. So when you go up, there's less oxygen available for you to take in. So there you go. As you go up, pressure decreases. All right, let's talk about some units with pressure. So we have atmospheres. That's one unit. Okay? Another unit we're going to have is something called kilopascals. Kilopascals. It's written as KPA. All right? And there's going to be a number of equations we use. So one atmosphere is equal to, I'm going to rewrite this because I don't have enough room. One atmosphere is equal to 101.3 kilopascals. That's a K. So KPA is what we call it. All right, we're going to do another one. Well, we're going to make them all equivalent to an atmosphere. So again, if you were standing at sea level, that's about how much pressure is on you. All right, one atmosphere is also equal to 760 millimeters of mercury. Alright, another unit we use is millimeters of mercury. Alright, if you ever know what a barometer is, they use that in like weather. They'll talk about barometric pressure rising or falling. In a barometer, it's this tube, okay? And basically, as atmosphere presses down, there's mercury in the tube that when it presses down, it causes the level to go up. Okay, so you're pressing down on this side, pressing down on the mercury, causing it to go up. As atmospheric pressure decreases, the mercury level goes down. And basically all they do is measure the height of that column to get pressure. Okay, so 760 millimeters, right? That's a measurement of length or height. Millimeters of mercury, so that's a pressure reading. Another one is 1 atmosphere is equal to 760 TORR. We call that torr. Okay, get that down a little bit. So 1 atmosphere is equal to 760, all right, torr. This is named after Torricelli, right? He's the guy that actually came up with the barometer. I think he was Italian, if I'm not mistaken, Italian physicist. All right, and then one more to go. 1 atmosphere is equal to, let me look at my numbers so I don't get it wrong, 14.7 PSI. All right, that stands for pounds per square inch. This is what we use in tire pressure all the time. So if you work with cars or bikes or anything like that, and you look at tires, this is tire pressure usually. All right, with all that being said, you will need to learn how to convert from one to another. So let's say I gave you 34.2 atmospheres. How many millimeters of mercury is it? All right, we've done flim charts in here before, so you might want to pause this. Maybe you can try it yourself. Okay, so 34.2 atmospheres. I throw into a flim chart. I go back up here. Here's my atmospheres in millimeters of mercury. And so for every 1 atmosphere, we have 760 millimeters of mercury. Throw that into our calculator. Multiply times 760. Divide by the 1. Right, and we'll get 25992 millimeters of mercury. Now, if you want to do that in sig figs, we'll say this conversion is infinite, so we'll just look at the beginning. That 34.2 has 3 sig figs. So this is equal to, if I was going to do sig figs here, a line over that 0 indicates its significance. The proper rounding, so it's equal to that. All right, we're going to do one more here, and then see you in class. Let's try, we've got 48.3 PSI, and I want to know how many kilopascals do we have. All right, I'm doing this one for a reason, because there's nothing up here that tells us how to go from PSI straight to kilopascals, but we can go to atmospheres first. So 48.3 PSI. I don't want pounds per square inch. What do I know about pounds per square inch? Well, I can go to atmospheres. So 14.7 of these is equal to 1 atmosphere. And then 1 atmosphere is equal to 101.3 kPa. So 1 atmosphere is equal to 101.3 kPa. Plug that in, 48.3 divided by my 14.7 times 101.3. And these we'll just consider infinite sig figs, so we only want 3 sig figs. So this time I'm just going to put the number down with sig figs. It'll be 333 kPa. All right, that's what you got to know for tomorrow.